Hey all, in today's video, we are going to implement machine learning project using Azure on housing price prediction. We will walk you through the entire process of building a regression model using Azure Machine Learning. From data preprocessing to model training and evaluation, we will cover it all. And by the end of this video, you will have a solid understanding of how to leverage Azure's automated machine learning tools to predict house prices based on various features like area, bedrooms, and more. And also make sure that you try out this hands-on project on your own because it's going to be a great addition to your resume. It's a strong project that will showcase your skills effectively. And don't worry, we have got you covered with a complete downloadable guide to help you every step of the way. And the best part, it's completely free. You can find the link to the guide in the description below and in the pinned comments. And also, if you feel stuck while implementing or have doubts, make sure to ask them in the comment section below. But that's not all. If you're serious about landing a high-paying job, we also have an upcoming free masterclass where our experts will share a proven 3-step framework and the exact roadmap the professionals like Shrija, Mark, Steve, Devashish and many others followed to land their dream AI/ML roles and top certifications. Both the links are provided in the description as well as in the pinned comments. So make sure that you check them out. So now let's get started with the housing price prediction project.
Just to give you an insight. So we are looking into machine learning today. We'll touch base upon machine learning. What are the types of machine learning? Though you must be aware, but let us just have an interaction. What are the types of machine learning? Okay, and then we will look into solving we will be solving a problem, okay, for one of the machine learning, okay, which we will be touching, okay, and then we'll be solving a problem for one of the machine learning type. For solving that problem, we will be using, you can say that we will be using Azure Machine Learning, okay, which is a service in Azure. Okay, so we'll be using Azure Machine Learning service. In that Azure Machine Learning service, we will be using Azure Machine Learning Studio. In that Azure Machine Learning Studio, we will be using automated machine learning. Okay, in that automated machine learning, the type of machine learning that we are going to solve will be a regression type of machine learning. And when we say regression type, what do we mean by that? We will touch base upon that. So we will be doing end-to-end process wherein we will inject the data. Okay, first thing, we will be injecting the data. Then after injecting the data, we will be going ahead and doing pre-processing on the data. Okay. After pre-processing, we will be training the model. We will also be, after training the model, we will also see the performance of the model, evaluation of the model. Okay. Evaluate the model performance. After that, we will register the model. Basically, you can say we will save the model on cloud. So we will save the model. Okay, we will save the model. Once we save the model, then we will go ahead and deploy the model. Okay. And once we deploy the model, then we can consume the model. This is what we are basically going to go ahead and do for today. This is what our aim is. Okay. Now, what is machine learning and what is the difference between machine learning and artificial intelligence? Okay. Now, the first thing that we are talking about is machine learning. We are able to make sense that machine learning is actually machine learning uses algorithm. It uses an algorithm that is able to find pattern in the data. Okay, pattern between the features and the target. Okay, this is what we call machine learning. Okay, so basically it tries to form a relation between target. Target is basically a function, okay, of features. Okay, this is what basically happens. Target is a function of features. This is what we go ahead and do. Second aspect that we need to understand is what is AI, or in sense you can call it as Gen AI also. So what is AI? AI basically is a you can say is a more like a system, okay, which runs those algorithms. So artificial intelligence does not only have machine learning; it has deep learning, it has optimization technique. There are so many things that are available, okay, as a part of it. So it is a system which runs your machine learning algorithm. Okay. So machine learning is like an engine and AI is your driver system. That is what we can say. Okay, at a high level. Okay, this is first thing that we need to understand. Taking you ahead, when we are talking about machine learning, there are different types of machine. So I hope we all are aware about regression. Then we are aware about classification. Okay, then we are aware about clustering. Okay, these three are famously known, and then there is also something called as natural language processing. Okay, okay, all these are different types of machine learning. Natural language processing. Then we also have time series analysis. This is also there with us. And then we also have something called as, you can say transformers. Okay. Just to keep it at a high level, you can understand that machine learning generally started with regression, classification, clustering, ended up with natural language processing, wherein people wanted to process the natural language through a machine learning algorithm. Okay. Then came to time series analysis, transformers, and there is also something very famous, which is being called as reinforcement learning. Now, to give you an insight about all this, when we talk about regression, here we try to predict a number. Okay. When we talk about classification, here we predict a category. And when we talk about clustering, this is where we try to find pattern in the data. This is also a type of category only, find pattern in the data and categorize them to build intuition. The aim is to build intuition, not to predict a class, but to build intuition on what has been predicted. Okay, so that it can benefit the business. Taking you ahead, when we talk about natural language processing, this is where you analyze huge amount of text. Okay, analyze text to do language translation. Okay, to do sentiment analysis. To do, you can say, language translation, sentiment analysis, intent recognition in the sentence or the document. Okay, anything that we want to do, we can do via natural language processing. When it comes to time series analysis, this is where we use regression, but one of the feature or one or more is time dependent. Okay, time dependent. Okay, like a stock market depends upon the day or maybe the hourly transactions that are happening. Then there is also something called as transformer. Transformer was able to solve the problem, if I put it this way. It was able to solve the problem, okay, of long contextual text. Okay, basic NLP algorithm. So if there was long contextual text, basic NLP algorithm where used to tend to forget, okay, the context. Okay, that is where transformer comes into picture, wherein there was a transformer architecture that was able to retain a lot of thing in the memory. Okay, based on a research paper, which we call as attention is all we need. Then there is one more type which I want to highlight, which is reinforcement learning, where it uses a pattern, format of loss or gain. Okay, if the user does the correct thing, okay, based on what you thought, okay, then there is a gain for you, or vice versa, or you can call vice versa. So this is what we have in place. Now, what do we have in this exercise? Okay, for today, I'll just take you through this project. So in this project, the first thing that we are going to go ahead and do is We are going to build a house price prediction with Azure Machine Learning. So when we say house price prediction, I'll just take you through the data. Okay, this is our data. And now what are we going to do? If you see this data, we have price, we have area, we have number of bedrooms, number of bathrooms, stories, like number of floors. Is it on the main road? Does it has a guest room? Does it have a basement? Does it have a water heater? Okay. Then does it have an air conditioner, parking, brief area? Okay. And then finally furnishing status. So these are the informations that we have. We are going to go ahead and go to portal. Let me just copy this. So let me go to portal. We need to create a resource by the name Azure Machine Learning. Let me click on the resource. And we need to hit on create button. I think if you are aware, that's great. I need to click on the workspace. And here I need to create a new workspace. Let me call it as resource group 001 maybe. Okay, I need to create a workspace name, which is going to be my service name. I'm just going to call it as maybe Azure Machine Learning. Okay, I can select a region of my choice. Let me select a preferred region. You can select any region. Okay, now these are the dependent resources that will be created, like a storage account, a keyword, an app insight, and a container registry. If you want to manage the inbound access and everything, other settings like inbound, outbound, encryption, identity tag, you can do that. Right now, I'll keep all the things to default. If it passes the final validation, we can just hit on create. Now, the moment I hit on create, it will go ahead and create a resource. And when it is going to create a resource, okay, when it is going to create a resource by the name Azure Machine Learning, it will create a resource which is going to be Azure Machine Learning. Then along with that, we'll get a storage account. Okay, we will also get a keyword, application insight, and a dashboard monitoring tool. This is what we will be able to get. So let it get created, and here you can see, we can see a dashboard monitoring tool like a log analytics workspace, application insight, keyword, storage account. And once all these dependent things are created, now we will be able to see a machine learning resource getting created. So we are just going through the main process of creating a machine learning resource. Let that be getting deployed. Now, once it is deployed, we can go to resources. And here we will have an option to launch the studio. So I can just click on launch studio to be able to launch the studio. I've just launched the studio now. Now, the moment we try to launch the studio, this is how the machine learning studio looks like. In this machine learning studio, we will be going ahead and making use of a machine to be able to run our model on automated machine. So I think you must be aware about this. Right now, let me just go to the compute. There are different computes like compute instances, compute cluster, Kubernetes, attach, and serverless. You can use any of the compute for training a machine learning model. Right now, I am going to choose the one which is compute instance. Now, if I scroll down here, we can see that we have a hit button which is going to help me create a compute instance. Now, this compute instance is going to get spun up within the Azure Machine Learning. So, during the interview, if someone asks, where did you create the compute? You can say that we created the compute within the Azure Machine Learning Studio. That is what we can go ahead and say. Now I am trying to create a compute. We just need to wait for a fraction of a second. And if it's taking time, let me hit on this again new. Just waiting for it to get, I don't know what might be the issue. Sometimes that kind of issues can pop up. So let me launch the studio again. Let me go to the compute again. And let me just hit on this new computer. I don't know why it is taking so much time. Yeah, now it's fine. I can give a name to this compute. I can select my compute, any compute type. There are lots and lots of options. In all options, you can see 215 PM sizes, and selected, you can see around 30-40 sizes. I'll go to the next. Here we have an option to enable auto shutdown after 50-60 seconds. If you want to do that, you can do that. You can even add your customized schedule that, hey, please spun up the virtual machine at 8 and then close it at 5 p.m. If you want to do that kind of a thing, you can actually go ahead and schedule the virtual machine at your own choice of time. Now I'll just click on the next. Here we can even assign it to other user. We can assign it to a managed identity. SSH can be enabled, virtual network, root access, everything we can go ahead and provide. We can add our own custom application, okay, that we want to run. Maybe there is some application that runs only in our organization and we want to install it onto this VM. We can do that. Right now, I'm just going to hit the create button and let the compute instance get created. So right now, the compute instance is getting created. Since the compute is getting created, okay, so if you have your Databricks, data lake analytics, HD inside, or if you have your own virtual machine, you can pass the IP and the username password, and it should be able to connect. That should be absolutely fine. And then you can use it to run your job. That is absolutely fine. All right. Let the compute instance get created and then we'll proceed. Why are we requiring the compute instance? Because I want to run an automated machine learning job. This is our project. Okay. Let it get created and then we'll proceed. It does take a little bit. I have already created, but I do not want to show it from there. That's the reason I'm creating it from here. Until that time, let us just do one thing. Let me open the housing data set. Okay. So if you see the housing data set, if I show you the housing data set, okay, here you can see, I can see the price, the area, total carpet area maybe. Then we can see bedroom and everything we have already seen, right? So now what are we going to do? Until it is not created, we just need to be a little patient and then we will go through automated machine. And now you can see the computer is running. Now I can go to automated machine learning. And maybe from the automated machine learning, I want to run a job. Now, what is the job? In this job, you can see that we have multiple options to fill. So this is like a UI wherein we need to specify the training method, which is going to be regression. Then we need to specify a job name. Let me just call as house price prediction. This is what I have specified, house price prediction. Okay, once I've specified this, then I can select a new because there is no experiment right now deciding. I can select my experiment name. Same I'll just use experiment 001 maybe. And now I can go to next. Now I can select a task type. If you remember, I'll go with classic regression. Then I want to create a data set. Right now, I do not have the data set. So I'll just hit on create. The moment I hit on create here, I can give a name, housing price prediction maybe. Okay, I'll give a same name, housing price prediction. Then we can select a data type. I can just select any data type. Now I can click on next. Here I can upload a data. The moment I click, I need to go to next to upload the data. So where do you want to upload the data? It will get uploaded in the storage. You can select any other storage that you have. I'll just select the blob store. Next, it is going to ask me to upload file or folder. So if I go to file, I should be able to see my housing data set. The moment I upload it here, it is going to pass the data automatically. Okay, and then it is going to ask me to specify where do you want to place. So I'm okay with the storage account. I'll just go to upload file. I think we already have got the file. Now, if there is any file format, delimiter, UTF encoding, or maybe all file header, if there are multiple files that are going to be processed to create a machine learning model, the first file may have the index, the second may not have the index. So you may say that I can say that only file has one header. Now I can see the whole data. Now I'll click on the next, and here you can see price, area, arena, everything. We can see it here. If you want to remove any feature, you can remove. Now I'll hit on create. So what I'm able to do right now is I'm just able to run the automated machine learning job. We'll look into the detail. I just want to take you through the high level overview that a automated machine learning job has been created. Now, if you go to the job section, you can, in some time, you will be able to see the automated machine learning job. But just waiting, maybe it is preparing the data. I'm not sure why the job is not getting reflected. Let me just go to the next. This is fine. This is fine. Let it pass the data. Everything is same. I need to select the task type, I guess, regression. Now I can go to next. And here you can see I'm able to preview the settings. So here I can select a target column. Now, can anyone tell me what will be our target column? We want to predict the house price. Which one? Sorry, price. Absolutely correct. Now, if you want to configure addition setting, you can do that. I'm okay with the automatic test validation set. And now I am going to specify the machine which is going to be compute instance. I can select my machine which is already running, and now I can click on it. And now I can submit the job. So what I was able to do, I was able to select the training method, which is classification, basic setting like experiment name, job name, okay, who will be the author, everything we can specify. Okay, then comes another thing for us, which is about model training, then evaluating, then prediction, deployment, and then prediction. This is what we'll be looking at. Okay, we'll be using a regression algorithm. And now it may take a little bit of time to get started this job. All right, let me take it ahead. What I was saying. So the point that you need to understand is what is ML. MLflow provides you a UI. MLflow provides you a UI, okay, for end-to-end tracing of a machine learning or a Gen AI project. Okay, it gives you a end-to-end tracing of a project, maybe a machine learning or a Gen AI project. When we talk about Azure Machine Learning, so I was talking about MLflow. Let me write it again. Provide the UI for end-to-end machine learning or Gen AI project. When I'm talking about machine learning, Azure Machine Learning, okay, it uses ML. It uses MLflow to track end-to-end machine learning, okay, in a UI, studio UI, okay. This is the difference in a studio UI. One more thing, when you do it end-to-end tracing, the resources are required, right? Where will you store the job? Okay. Where will you store the metadata? Where will you store the metrics? Where will you store the artifacts? Okay, all those things will be decided by you. You will decide. Okay, where to store. Okay, but when you use Azure Machine Learning, all those aspects, okay, track, you can track, uses MLflow to track within the studio, and whatever you want to store, okay, whatever you want to store, it is stored within the studio UI itself. Okay, like job, metadata, metrics, artifact, model, anything. Model has artifact means model only, right? Model and retraining of the model, anything you have. Okay, you can check it here. Okay, and that is all stored within the Azure Machine Learning Studio. That is the difference. So it uses ML, which is an open source package, to be able to track machine learning in a studio UI. And when I say MLflow, it provides a person, you can see it provides the open source UI, wherein you can track the end-to-end machine learning project via the Azure Machine Learning, or maybe via your local system, or maybe via AWS, GCP, anywhere you want to track, you can track it. Is that making sense? If you're using, suppose you are onto the portal, okay. Okay, you are onto the portal. Your data is there in some storage, Azure storage, some storage service. Okay, data is in the storage service. Okay. Apart from that, you can say the compute is also there as a part, maybe a virtual machine that you have attached. I'm just giving an example. Virtual machine. You can even take a compute, right, from the studio itself. But suppose there is a virtual machine, okay, which is going to act as a compute, acts as a high-end compute, okay, to train the model. But for hosting the code with environment, again, understand what I'm saying? You want to use compute instance. You're okay with that. compute instance. For the environment, if you want, you can use for the environment, you're going to use that available environment. So you're going to curate the environment here itself to build the environment and then use the environment, build and use the environment. Okay, you are again going to use environment variable. There is environment thing, right? Environment, I'll put it this way in Azure Machine Learning Studio. This is what you'll do. Okay, environment in Azure Machine Learning Studio. Now, when I'm saying all this, your storage, there in the Azure, compute in Azure, host code is hosted in Azure, environment is built in Azure. You're getting my point? In that case, what will you use? You will use Studio, right? And when you're going to use Studio and you want to track your project, how will you track? Within the Studio, if you want to track the project, how will you track? You will call the package Azure MLflow. Simple. Okay, to be able to track it within the Studio because you have everything within the Studio. Now consider another scenario. What I say another scenario is the data is stored locally. Okay, or maybe in my personal data center, company data center. Understand what I'm saying? Okay, and compute is my local compute. Okay, I've built a GPU compute local, or maybe a company's data center. Okay, I can just put it as data center. Okay, again, hosting the code, I have another application system for hosting the code. Just hosting the code with the environment, the required environment. Okay, not running the training. Here I'm going to run the training jobs. Okay, yeah, I'm just saying hosting the code along with environment. Again, I have a compute, a very good compute. Okay, maybe a local data center. Getting my point? Environment, I already told you with environment. Now, in this case, I want to do end-to-end tracking. Now, why will I go to Azure? Not required, right? So, what will I prefer here? I'll directly use pip install MLflow and then use the methods to be able to go ahead and use my code, everything I want to locate it somewhere. I can do that. Is that making sense now? This is the place wherein you can create an environment. Workspace can have as many environment as you want. You can build multiple, you can run multiple jobs. Each job can give you multiple models, and each model you can keep it as a version also, or you can keep it separately, whatever is yours. And then you can deploy any of your models, whatever you want to deploy. So I have already got some model. Now let me just select one of the models. Maybe I'm going to select this model. There is an option. This is what is there in your lab. Right? So now you can just deploy a model as a batch data, as a web service, or as a real time. Let me click on real time endpoint. What is the difference between this and this? In the web service, okay, you are going to control the company where you will deploy. Okay. And in the real time endpoint, okay, Azure is going to control the compute. I'll show you. Azure is going to control the compute. Batch, you can pass batch of data. Simple. If you have batch of data wherein the information, okay, prediction is not required in real time, you're okay to process a batch of data. Maybe at a scheduled interval, then you can go for a batch. Now, one more important thing just to highlight before we deploy the model to real-time endpoint or a web service. Right now, you can see that the model is not registered. That means everything, if I go to job, if I go to my experiment, and if I go to my experiment name, and if I go to my model plus child job, the experiment is still running and it will take a lot of time because I have allowed all the algorithms. Okay. Now, if I see all these are my algorithms. So if I select any one of this, every algorithm has got some metrics. How is the experiment registered? No, but the experiment has been created and I can see the output of the experiment. We can deploy this as a model. So we have got actually the model with some root mean square error, which is pretty less 0.09. The model is not registered. The moment I click on this and go to real-time endpoint, here you can see it is going to select the project name. It will ask the instance count. Since I do not have this much instance, let me select 2. So 2 instance count. This is the virtual machine, $0.10 per hour. I can give an endpoint name. I can give any endpoint name, house prediction endpoint. Okay, I'm just giving the endpoint name. After giving the endpoint name, I can give the deployment name also. If you want to keep the same name, you can keep the same name. That's up to you. Okay, I'll just give some name, deployment name. If you want to infer the data, maybe you want to collect the data that the user is going to pass, it all gets connected in the application inside so that you can even check for data drift if the response is not coming worthy enough. You want to package the model, you can even package the model as a Docker image, or you can hit on deploy. The moment you hit on deploy, I want you to focus here. The model is not yet registered and the deployment status is also not deployed. The moment you will click on this, it is going to deploy the model. Before deploying the model, it needs to store the model as a model. Okay, so right now no model has been registered. After some time, you will see a model will be registered here before the deployment happens, because from where it is going to pick. Now you can see the model has been registered. If I go to the model, the deployment is still pending, but the model has been registered. Now, if I go to the deployment, here you can see this is my model, and you can see that the model is of MLflow type. And I want to download the model. I can even download the whole model, okay, which is an artifact. I've just downloaded the model. Yeah, can you see the model has been downloaded? Now, if I go inside this, you can see that I have got the model in the pickle file. This is my model. This is my configuration file, environment configuration, Python environment, requirement.txt, everything is there. So the moment you do this, you know what happens? Actually, this same model, if you go to the artifact, you can see this is what I'm talking about, the artifact. Okay, these are all the artifacts. This is the version of the model, which is version 1 right now. Okay, and then you can see this is coming from which job. If there is any job, data, endpoint, you can check everything from here itself. Right now, this does not have any endpoint. Let me go to the endpoint because I'm just deploying the endpoint, right? Now, this is my endpoint, house prediction endpoint. And here you can see this is where the deployment will happen. And it will take some time, but it will automatically create the scoring script because MLflow automatically has the capability to be able to read the model, the injected data, and being able to go ahead and write a scoring script for you automatically. So let this happen. All right. When you say batch data, suppose there is a doctor, okay, who takes care of patients, and the patient are asking, hey, whether I'm diabetic or not. Okay. And this patient are asking whether they are diabetic or not, but they are okay to wait. Right. They want a report. I'll just give you a simple thing. They are okay to wait and they want a full report. I'll put it simple. Okay. Doctor is saying, I'll not take your blood test. I'll not do anything. I just need your data. Give me your data. Okay. Maybe some information about what is your blood pressure and everything. I'm just going to check for that. Okay. Some information. Okay. Need your data. So you pass the data. So suppose doctor is sitting from 8 a.m. to 8 p.m. in the clinic. Okay. And after 8 p.m., he does not want to run the model for each and every customer. Right? So what he wants to do, every hour on an average, suppose 1,500 people are coming. But tell me, is it feasible for this person to enter the information and be able to interpret it correctly? No, right? So what he is going to do, 1,500 into 12, if you consider, it is going to be 1 point something, right? I think 1.8. How much it will be? 1,500 into 12, 12 hours, right? 180. Is it correct? 18,000. So 18,000 sample people are asking. So what he's going to do, he'll accumulate all the data. He'll create a sheet. 8 a.m. to 9 p.m. he'll create a sheet. 9 p.m. to 10, 8 a.m. to 9 a.m., 9 a.m. to 10 a.m. He's creating multiple sheets. Okay, all the sheets have headers. Okay, so all the sheets have headers. Now there are how many sheets? For 12 hours, he was able to accumulate 12 sheets. Why is that 12 sheet? Because the nurse sits only for 1 hour. Assume or suppose the nurse shift is 6 hours. Okay, 6 hours. So how many sheets will be able to accumulate? 2 sheets he is able to accumulate. Okay. So now what I'm trying to help you understand, 6 hours, 1 sheet will get filled. Another 6 hours, another sheet will get filled. All the data will be there together, which will be 1800 data points. Okay. And now in this data point, we will have the information like what is your blood pressure. Okay. What is your family history? Okay. Do you take salt or what is your sugar intake? Okay. Every day, how much intake? If you can give me a rough estimate, how many spoons? Just helping you understand. Okay. Do you eat non-veg? Okay. All those aspects are being known. So now passing all this information over and over again or making customer enter is not a good thing, right? So what I'm going to say, I am going to run this model. Once the data is being accumulated, I'm going to run this model at maybe around 8:50 p.m. Okay, I'll pass all the data to the model. Wherein one factor is still pending. Which factor? Diabetic or non-diabetic. The next one is pretty simple. The next one is pretty simple. Just go to the model or maybe go to the job, select the main job, go to the child job, select any child job that you are interested, select, go to deploy and see the difference. Deploy as a web service. What it is saying? It is asking you to give me the compute. Where is your compute? Do I have a Kubernetes? No. You're getting the point? So here I told you will provide the compute. Everything will remain same. The compute will be taken care by you. Real time. It's saying, hey, I give you the compute. Do not worry. These are some of the computes that I have available. Are you okay to use it? And I'll get it deployed for you. That's it. So now let me just go to this job. I have already run this job. This is my job. Here you can see it is still running 307. If you see 307 set of experiments have been executed. It's been running from, I think it will take all my resource. I need to stop it urgently. So now you can see there are so many things that I have. Each page has 25 and there are 13 pages that I can see. So this many experiments I have got in place. If I go to the model, I have deployed one of the model. You can deploy any model absolutely fine. Okay. And then if I go to the endpoint, here you can see I've deployed a real time endpoint. And here you can see this is the deployment. If I go to test, I can test it here itself. Then I can consume it over a script. Can you see I can consume it over a script? I have got the endpoint. Okay. And if you want to, I told you, you can use this directly to be able to consume. That's absolutely fine. Okay. Right now, I'll just go to the test and I want to test this, right? So I can pass the data here itself. If I come up here somewhere, we have got a data. Let me just copy the data from here. Everything I'm taking it from here itself. So this is what is expected. Right now, let me just do one thing. I'll just take 724, 7420423. I need to pass the data here, right? Yes, no, 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 yes. Let me pass it absolutely same. This is the string. Yes, no, 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 yes. Two yes furnished. This is what I'm passing here to be able to get a response. Some issue. Let me just check. Show why I'm not able to get the response. Let me just check the columns. Unexpected. Check the log. There is some issue. Failed. Unexpected errors occurred in scoring script. All right. Then I can't help because the scoring script is auto created. Let me go to the log. Not sure if that is the case. Let me just do one thing. Let me consume it this way. Now there is an endpoint, there is a key, and there is a script, right? You get the script in Python, C Sharp, JSON, or even JavaScript. I wanted to test it here, but there was some issue. It is saying. I'll just check that out. Let me just do one thing. I want to consume it, right? So to consume what I'm going to do right now, I'll go to my studio again. Let me open Azure Machine Learning. The deployment is successful. I just need to consume it. So now let me go to the studio again. I'll go to the compute maybe. I'll open my Jupyter lab maybe. I'll just open the Jupyter lab. Let me create a new notebook. Sorry. Let me create a new notebook. It's creating a folder. Just creating a new notebook right now. And in this notebook, I'll select the Python. I can select anything else. I'll just select, maybe I can select anything, right? So I can select Python 3.2 SDK version 2. Anything that I want to use, I can use. Okay, right now I don't think it requires this SDK version 2, but you can select any environment of your choice. We can check the documentation, which environment ever are we required to use. But right now, I think the first one should work. That should not be a problem. Now, what I'm going to do, if you say this is the script, because you copy the script, whatever you have. So let us just paste the code, whatever we have from here, and we'll go through the code also. We can just paste the Python code. We have the Python code. Okay, let me just select this. That's fine. Okay, so I've just pasted the Python code right now. If you see, it is expecting some data. Okay, this is my scoring endpoint. Now it is expecting an API key. Okay, so I need to pass an API key. Let me pass an API key from here. This is the key. Let me copy. Come here. Let me pass the API key to be able to access this endpoint. This is the same endpoint that we can see here. Okay, so right now this is the endpoint and I want to pass it via an API key. This is where we are actually going ahead and calling the endpoint. Okay, and we are passing the header and then we are making a request and then we are able to get the response. Okay, read the response and finally you can say read the response and print the result. This is what our aim is. It expects something in the body, which is the data. So now if I scroll down, we have just pasted this. Okay, so we have just pasted this. After this, we've had to paste this 2 point, which are already pasted. Okay, after that, I told we can try it here. We did try, but it was not working. We need to paste the input data inside the curly braces. So where is the input data? We can check the input data. This is the input data that it is expected us to go ahead and paste. I think this was absolutely fine. Does it expect two brackets? Maybe I'll just check. This is the same script that we have. So we can use this also. This is the data. Let me just copy this data from here. Getting copy pasted correctly. Some issue. There is an issue in the scoring script log. I need to check what might be the log issue. Let me just check. Let us just refresh. If the issue is in the log, then it might be with respect to some deployment. The the Kubernetes may not be available. That pod might not be available. That can be one of the things. So let me just do one thing. Let me just remove this from here. As a limitation. So let us just try. Container image might be an issue, to be very honest. Let us just check. Status is success. Container is ready. Serving is fine. Health check. Scoring. The critical is unicorn access. This is for Python. Some issue with respect to this. It is expecting the data in this format. So let me just do one thing. Input data. The same issue it is shown. Just need to check what might be the issue with respect to how to pass the data. That's the only thing. It should have been able to take the value directly because it is taking this input and here this is where the data should come. If this is the case, let me just do one last thing. Maybe I need to pass it as a list within a list. Failing error is coming. I don't know what might be the error. I just need to check what might be the error. Perfectly valid. I don't see anything as an error to be very honest. When I feel that there is no error, nothing. Just try it out from your end. Maybe some, I personally feel maybe some issue. It's a JSON object only. It's absolutely fine. This is not required. It will be fine. I'll just check this out. Actually, we can consume it to be very honest. This is reported by the front-end service issue. The value is not provided for the input data parameter, which has been provided to be very honest. I'll just check this out, but you can check this out, guys. If there is some issue with respect to maybe the deployment, then we can check that out. Is that okay? If that is okay, let me just take you through another thing, like what is basically going to happen when you'll pass the data. You should be able to get a response. This is what you'll be able to get if you go through it. Because the deployment, everything is successful. There should not be any problem with regard to this. Once you pass the data this way, the same thing that we are also trying to pass. When you pass index, maybe I need to pass index as equal to 1. If that is the case, let me just. Yeah, we got the result. The index was required. We got the result. Index we need to pass. Now just need to add it into the script, right? Has worked. We are able to get the response. The only thing is body will take the data, dump the data, go to the URL, take the API key, then it will take the application, the data in the JSON format. Authorization is API key plus bearer token. We'll get the response. It should work now. Let's give it a try. We have got the response. So the things are on the same line. We just need to complete it. So we were able to look into this. And if you see, this is the machine learning endpoint. The same machine learning endpoint, you can just see it here.
So that's a wrap for today's project on housing price prediction with Azure. We covered everything from setting up the Azure Machine Learning Studio to deploying the model and consuming predictions. So I hope this gives you a great foundation for your own machine learning projects. So now it's your turn. Try building the model on your own and experiment with different features to see how they affect the predictions. And if you have any questions or run into any issues, leave a comment below. We will be happy to help you out. And remember, if you want to take your AI/ML skills further, sign up for our free masterclass on AI, machine learning, and agentic AI. It's packed with insights to help you land high-paying roles in the AI/ML field. And also, if you found this video helpful, make sure to hit the subscribe button for more such easy-to-understand tutorials. So thanks for watching, and I'll see you in the next video.